Good evening. How are you all doing? I can see Suhani is here. Shakil is also here. Can we quickly refresh the chat so that I can see who all have joined in? Good evening all of you. Hey Bishal. Bishal really loves chemistry. Great, good to know that. You know, such comments, it just makes our day. Urmila is here. Good, good. Okay, you knew you've just joined in. A very warm welcome. I can see that. So I hope you will try that model as well, Vishal. Hey Urmila, I'm doing really well. I hope you're doing fine too. Thank you, Regu. Hey Sonal, Lisa, Sanjana. I can see all of you slowly joining in. Quickly let your friends know about this. Hey Tavishi. Tavishi has also been really regular. Hey Ibrahim, I'm doing really well, thank you. Hey Muskan, I'm right here. Good evening all of you. There's somebody named Chota Bheem as well. Prikshit. Some new names are there. So it's always good when we see new names, new people joining in. It's always amazing. And of course, the ones who are always regular, we will always make our day. We keep saying that. Hey Lakshit, Seenu, Vasi Kamar. Good evening all of you. Hey Avi, okay. Note it, Avi. Great. Quickly let your friends know about this session so that we get started. Meanwhile, we can have a view. We can look over this and discuss this amazing app. So you'll get amazing video sessions in BYJU'S, the learning app. How many of you have already downloaded? Let's see. Because this app is all about personalized learning. See, learning graph for each one of us is very different, isn't it? It's a unique graph for each one of us. So we need personalized learning. And there you go. This app is the best suited for that. I see a lot of you write me. That is absolutely great. Great. Okay, what about the scholarship test? I hope you have registered for this as well. If yes, you can share your experience over here with me. Correct. So by giving this scholarship test, you'll know about your strength, you'll know about your weakness, what are the problem areas. Hey, Vasi Kamar, good to know that. And of course, based on this, you can again have a very personalized study plan. Given it yesterday, yes. So yes, every Sunday, that is happening. Up to 100% scholarship. I think that's really amazing. I can really put a big smiley face over here. Good. See, when your preparation is nice, you start finding questions easy. That means you were very well prepared. Great experience. Good to know that. Great, guys. Alright, so before we get started, you know the drill. You know what you have to do. You have to let me know if you can see me properly, hear me properly. This entire setup is working fine. You can see the PPT, you can see the smiley face. You can read this hi. Everything is working fine. Then just flood this chat box with a lot of positive energy, a lot of interesting emojis, and then we get started. Let's see which is your favorite emoji. Put lots of positive emojis. Let's start today's class on a very positive note. Great, now I can see some interesting emojis coming in. Awesome. Smiley faces, laughing faces. Love for chemistry, awesome. You're from Amritsar, good to know that. Okay, we've got meditating faces as well. Great. Dabs and everything. Awesome. All said. That means on this positive note, we can get started. Yes, I remember you. Definitely. Some of you have been so regular that we've started remembering your names now. Hey, Himani. High five. Yes, Muskan. Alright, so curious fellow, what's your name? And this person has posted medals. And virtual medals for the ones who have actually attempted the homework question. Lakshit saying, I am the chemist of my class. That's the confidence we're looking for. Great. Hey Priyanka, Goransh. Super duper excited, so am I. Alright. First of all, let's see who all have done the homework question over here. If you've not done, I can see your comments over here as well. You can still try. You can still let me know the answer. Hey, Duster Gamer, you need to tell me your name for that. Okay, I can see answers are coming. It's okay, Muskan. You can always attempt now. Great. Yes, you can read the question. The question is right there. Let's see how many of you have actually done the homework. I can see that. I can see a lot of you posting the answer now. So I'm giving you some time to figure out. Okay, let's do one thing. Let's answer this question together first, and then I'll come to the ones who've actually taken out time to comment. So which of the following is not formed? This is what you had to read properly. See, it's very important to read the question really properly. Otherwise, we know the answer and still we mark the incorrect one, thinking it's the correct one. So develop this habit of always reading the question very nicely, properly, okay? So, which of the following is not formed when lead nitrate undergoes thermal decomposition? Thermal, which means that all this is happening in the presence of heat. This is also something to keep in mind. So, decomposition in the presence of heat. Is it lead oxide, nitrogen dioxide, oxygen gas, or carbon dioxide gas? So, let's get started. Over here, we have lead nitrate. Yes, and this lead nitrate is undergoing decomposition reaction. What is going to be produced? We have lead nitrate decomposing to give you lead oxide, nitrogen dioxide, and oxygen. But if you'll actually look at the options carefully, option D was carbon dioxide, which is not here. So yes, carbon dioxide is not being produced, and we can definitely rule that out. So what is not formed? Option D, that is carbon dioxide. Got the answer right? I see a lot of you marked option D. Awesome. So I'm going to tell you who all have attempted this question. If I take your name, you have to post loads of smileys in the comment section, okay? Alina, Soumya, Bishal, Samyak, Sneha, Lakshmi, Sushant, Namandeep, Ambar, Ibrahim, Mahamaya, Ishika, Tavishi, Arundhati, stylish rockers, okay? Who is this? Supriya, Andy, Nasira, Sonal, Smiley, Likita, Vaibhavi, Urmila, Suvarna, Nitya, Lakshmi Devi. So many of you. Well done, guys. I keep telling you these homework questions are really important. So, they really help you monitor your learning. So, yes, go ahead. Always solve these homework questions. And I think you feel really good when you get the correct answer. Isn't it? Hey, Ragveer. Lakshit. Great. Yes, Ishika is agreeing completely. Alright. Now, in the last class, we also talked about exothermic reactions. These are the reactions in which heat is basically released. Remember, it's being produced. Then we talked about endothermic. In this, heat is absorbed. So, in a way, it's needed, right? So, we discussed about exothermic, heat is being released, it's being produced. Endothermic, heat is needed, heat is absorbed for that reaction to take place. Then we talked about combination reactions where we had multiple reactants but one single product. And then we talked about the opposite of this, decomposition reaction, where we had a single reactant breaking into multiple products. If it's happening with the help of heat, we call it thermal decomposition. If it is happening with the help of light, you can call it photolytic decomposition or photolysis, and of course it can happen with the help of electricity as well. So we've had a quick recap of whatever we have done. Right, now what is the agenda for today? What are we going to master today? Let's have a look at this. So over here we have, for today's session, we are going to discuss about displacement reactions. Then we'll be discussing about reactivity series, and of course we will be giving you a homework question. So let's master this very important topic of displacement reaction together, and let's get started. Alright, now look at these two reactions, and I want to know from you what is common in these reactions. We have zinc that is reacting with hydrochloric acid to give you zinc chloride and hydrogen. In the second reaction, we have zinc reacting with copper sulfate to give you zinc sulfate plus copper. Quickly, you have to be really fast in replying. Yes, quick start, and you have to be really quick. That's how I'll actually understand कि yes, ये लोग बहुत जल्दी सोच रहे हैं, फटाफट से answers दे रहे हैं. Okay, you see some displacement, some replacement happening. Correct. In the first reaction, you can see zinc is basically taking the place of hydrogen. All right. Correct. In the second one, zinc is taking the place of copper. And this brings us to a very important type of reaction that is going to be, you can guess the name. Yes, it's taking the place of hydrogen in the first one and copper in the second one. Correct. What's the name? Muskan has already answered. Correct. So, this is nothing but displacement reaction. So, what happens in a displacement reaction? It's a type of chemical reaction in which one element displaces another element from its compound. We will be modifying this definition towards the end of it also. Let's see how. But as of now, what did we observe? We observed that there was one element that was in a way displacing the other element. So if you look at this equation over here, A plus BC giving you AC plus B. So in a way, we can say that A is actually displacing B over here. Yes, A is displacing B and taking its place, right? It's pushing away B and it's taking its place. Yes? Correct. So in a way, let me just remove this from here so that you can see how this is happening. See, it just pushed it away. Correct. Absolutely right. Alright, now here we have a test tube containing zinc metal and HCl acid. Okay, and clearly you can see some chemical reaction is taking place over here. But wait, let's go back a bit. Let's understand this reaction from the scratch. Let's have the before and after version of this. So, initially, we have a test tube containing HCl and zinc metal is being added to it. Right? Over here, after some time, what do you see? You see some bubbles coming, isn't it? Now, what do you think is responsible for these bubbles? Let's see. I'll give you the equation. We have, in a way, zinc is there and it's reacting with HCl to give you zinc chloride plus hydrogen. Now tell me. Sanjana, rethink. It's not oxygen. What is happening? We have zinc reacting with HCl to give you zinc chloride plus hydrogen. Correct. Yes. So, in a way, the bubbles that you see over here, they are of hydrogen gas. So yes, you can put an upward arrow over here. That's depicting evolution of a gas. So in a way, what do we have? We have zinc displacing hydrogen. Yes? Alright, let's understand another example now. Slowly we'll develop what is the concept of displacement reaction and then you'll never forget it. Okay, so we have zinc and that's reacting with copper sulfate. Again, let's break this reaction into before and after. So there is a beaker, okay, and this beaker initially we have copper sulfate in it. So you can see that is blue in color. So beaker containing blue colored copper sulfate solution. And then you can see a zinc rod is being basically added to it. Sorted till here. Now after some time you can see that the solution has turned colorless. Now you see some reddish brown coating has appeared. What is happening? Hey Tavishi, I'm going to come to your point pretty soon. This difference between displacement, double displacement. For that you first need to understand what is displacement, right? Reaction with copper, rusting. Think about this. Hey Mayank, absolutely right. So zinc is in a way reacting with copper sulfate to give you zinc sulfate plus copper. And this zinc sulfate that you see over here, the solution is turned colorless and copper deposits are visible. So in a way we can say zinc has displaced copper. Yes, now one really important question comes, how to decide which element can displace the other element? We saw that, one element was displacing other. This was the observation. Is it like some hit and trial or there's proper chemistry behind this? What do you think? Proper chemistry. Okay, so let's understand this. And to answer this, we need to analyze the equation that we just discussed. So we had zinc and we had copper. Yes? Now, what did we observe? We observed that when zinc was reacting with copper sulfate, zinc sulfate plus copper was being formed. So, what can we conclude from this? We can say that zinc is displacing copper from its compound. This is the overall picture of what we've discussed. Now, what's going to happen if copper is reacting with zinc sulfate? Now, we've reversed it. We had zinc reacting with copper sulfate. We had those observations that we've just discussed. Now, we are asking about the reverse. Copper plus zinc sulfate. What is going to happen over here? Well, we have a test tube. In that test tube, we've kept zinc sulfate and copper is there. Let's keep waiting. Let's keep waiting. I see a lot of you writing no reaction, ma'am. There is no need to wait because nothing is going to happen. Nothing. I see all of you write nothing, nothing, nothing. No reaction, no reaction. No. A lot of no's are there. Okay. You people are absolutely right. So no reaction has taken place over here. I might have waited for another good 30 minutes and nothing would have happened. Right? So I'll agree with you that no reaction is taking place over here. So zinc plus copper sulfate giving you zinc sulfate plus copper, that is sorted. But the reverse is over here giving us no reaction. In a way, we can say that zinc is able to displace copper, but copper cannot displace zinc. It is safe to conclude this. If yes, then give me a quick thumbs up in the comment section that yes, ma'am, it is very safe to conclude this. Hey Muskan, we're going to come to the reason really soon. Right now what we are discussing, hey Himani has already answered that. Okay, right now what we are discussing is what is actually happening. What have we observed? Sahil, I'm going to give you a great way to remember that. Good, awesome. So zinc is more reactive than copper. This is what we realized, right? Zinc was more powerful, it was more reactive, it is able to displace copper, but the vice versa is not true, right? Alright, now over here it is sorted till here that zinc is more reactive than copper. Now, coming back to the initial question that we had, what must an element be in order to replace another element? It has to be more reactive. It has to be more powerful. If you have to displace, in a way you have to be more powerful, and in terms of chemistry, more reactive. Now, moving on. We've discussed about zinc, we've discussed about copper. What about other elements? We've got so many elements, right? So when this same experiment was, done using zinc, copper, iron, aluminium, these four metals and their respective sulfate solutions. So zinc sulfate, copper sulfate, ferrous sulfate, aluminium sulfate, the following observations were being made. So all these metals were taken one by one, and let's see what did we observe. Zinc reacting with copper sulfate giving you zinc sulfate plus copper. We've discussed this. So as I show you the next equation, the moment you understand, you give me a thumbs up that yes, we've understood this. Okay? Your task right now is, whenever some equation comes on the screen, you understand it, you post loads and loads of thumbs up so that I know that till here everything is crystal clear. This equation, I see a thumbs up, iron is already given, okay. But the reverse was not true. Copper plus zinc sulfate is not giving you any reaction. Next, zinc reacting with aluminium sulfate, again no reaction. But over here, when zinc reacts with ferrous sulfate, we get zinc sulfate plus iron. And finally, iron reacting with copper sulfate, giving you ferrous sulfate plus copper. So these were the observations. Now, based on this, we can decide which is more reactive, which is not. And these metals can be arranged in this way. Aluminium, more reactive than zinc, more reactive than iron, more reactive than copper. So, clearly we can see out of the 4 metals that we've taken, aluminium is the most reactive and copper was the least reactive. Slowly we are moving towards reactivity series. Yes, correct. Yes, Preeti. Absolutely right. Now some more elements are being taken and they are being placed in this series like this. Again, you can look at the most reactive one. So now you've got potassium as the most reactive one and you've got silver as the least amongst the metals that we've taken. Yes, potassium, aluminium, zinc, iron, lead, copper and silver. And this leads us to the most important point of this session, that is reactivity series. Now, in this, as you can clearly see, it's basically a series in which we are arranging the elements, metals in this case, in the decreasing order of their reactivity. So the most reactive one at the top and the least reactive one at the bottom. So let's arrange these. Now you must be thinking, I'm sure, looking at these, okay, these are so many. You'll maybe afterwards have to have a, take a screenshot, zoom in. So we've placed some more elements, but yes, just the the shortcut way is also going to be there pretty soon. Out of the list that we've shared with you, these are the important ones, okay? And now you must be thinking how to remember these. You know that the most reactive one is at the top, you know that the least reactive one is at the bottom, and as you go from top to bottom, reactivity is decreasing. We are sorted till here. But how to remember what's the order? This might be a question that's popping in your head right now. Don't worry. We keep saying we've got you covered and there's a reason. So we'll give you a method, we'll give you one short trick to remember the series. And yes, of course, you can come up with your own mnemonics as well. So let's see what do we have for you. Over here, please is for potassium, cent, sodium, Charlie's, calcium, monkeys, magnesium, and aluminium, zebra, zinc, in, iron, large, lead, cages, copper, most, mercury, securely, silver, guarded, gold. So please send Charlie's, monkeys and zebra in large cages, most securely guarded. Just remember this and you would know the entire reactivity series. Hey, Himani's come up with another one. Please stop calling me a cute zebra. Yes, you can go ahead with that one as well. Amazing. But we also noticed when we were actually discussing the reactions, we noticed there was zinc, there was copper, there was hydrogen also. So let's do one thing. Over here, as you can see, you see lead and you see copper. In between lead and copper, you can actually place hydrogen so that you know if some compound with hydrogen is given, then what to do. Yes, after silver, gold, then platinum would come. Vishal. Yes, Tavishi, good one. Himani, awesome. Great. Alright, now that you know about the reactivity series, I have a question for you. Are you all set to solve this question? Yes? Let's see. Let's see what the question is. Which of the following metals can displace zinc from its solution? Think about this one. You will be given 60 seconds to solve this and your time starts now. Is it iron, is it copper, is it lead or is it aluminium? So in a way, What you have to see in this is which is above zinc in the reactivity series. You people seem really confident about the reactivity series. I saw the comments where you were coming up with your own mnemonics and you were posting loads of smileys, loads of thumbs up. So I am thinking that you will get this one right. Still 30 seconds are left. If a poll appears, you can mark the answer. If not, you're still given 60 seconds. That's okay. You can write your answer here and I can always read it. Most of you are voting for the same option. Good to know that. मतलब ठीक है, आप लोगों ने बोला बहुत confident है and I can see बहुत confident हो भी. You're proving it right. But I see some of you mark other options as well. So we will definitely be discussing this. Great, last 5 seconds, clock is ticking quickly. Awesome. Time's up and the correct answer is option D, aluminium. Yes, Sahil, it's going to be a mixture of Hindi, English both. Don't worry about this. Now, which of the following metals can displace zinc? If it is displacing zinc from its solution, it has to be stronger than zinc. It has to be more reactive than zinc. Yes? Now, if you will go back to the reactivity series, you will notice that aluminium is above zinc in the reactivity series. Rest all the elements are below. That means they're not that reactive and they are, in a way you can say, not that strong enough to displace zinc. But aluminium is. There you go. That was the correct answer. If you've got this one right, I want to see loads of smileys in the comment section. Loads of smileys. Let's see how many of you are actually feeling proud of yourself after getting the answer absolutely right. Hey Vishal, you have to see which is being placed. Placement of elements, absolutely right. Depends what is the compound that you're taking. Correct, I see smileys. Okay, I see a K. Is this OKK or is it potassium K? I just see a K being written. What is this? Okay, it is potassium one. Alright, yes. Done. Great. So, I told you we're gonna, in a way, mold the definition of displacement reaction. So, there you go. It's a type of reaction in which a more reactive element displaces a less reactive one from its compound or salt solution. This is going to be the exact definition for displacement reaction. Now, over here you can see A is reacting with BC to give you AC plus B. So, it is safe to write that A is in a way more reactive, yes, and B is in a way less reactive. And there you go. This is the complete definition for this. If you've understood this, I can see you post loads of cute zebras in the comment section. Great. Yes, absolutely right, Preeti. So there you go. This is what a displacement reaction is. And as promised, we are going to give you a homework question. Which metallic spoon can be used to stir lead nitrate solution? Use the same concept, guys. Sodium, silver, iron or aluminium. And you can post your answer in the comment section below after the live session. So if you've understood what is displacement reaction, quickly like this video. Not right now, post the answer in the comment section right after the live gets over. And yes, with this we've come to the end of today's session and we've mastered displacement reaction in just 30 minutes. And you can get this PDF and much more on Telegram. So join us there. We are waiting for you over there. And yes, I keep telling you, we've definitely got you covered. For sure. And yes, BYJU'S classes with 2 teacher advantage, something really important for everyone who's looking for superior learning and result. This is your one-stop solution for everything. So you'll get one expert teacher for your conceptual clarity, another one for solving your doubts. Try this out. The link is there in the description box. Go ahead and take this free trial class for sure. And of course, don't forget to like this video, subscribe to our channel and hit the bell icon for sure. And think about this one. We talked about Displacement reaction taking place in case of metals. Can it take place in case of non-metals also? So put on your thinking caps, figure out, explore, and then we'll discuss in the next class. So keep exploring the magic of chemistry, keep working hard, and I'll see you in the next session. Take care, bye-bye.